Still in the part 3, undamped horizontal mechanical oscillator. Now we'll talk about the graph of energy in this case. So let's see now first the graph of the energy with respect to x. So in terms of x, we'll write we know that there's no friction, and we know that we have, in the case of a horizontal spring pendulum, so this is x, and this, for example, the origin. So at any time t, we have first the potential elastic energy, which is equals to half kx squared. We also have the kinetic energy, which is equals to half mv squared. Now, in order to represent it in terms of x, and we have also the mechanical energy, which is equal to half kx squared plus half mv squared. Is the sum, and we know that there is no friction. This means we know that the mechanical energy is constant. So if we want to trace or to represent the energy in terms of the x, this is the energy in joules in terms of x. So the constant part, it's the mechanical energy. Here we have the mechanical energy, and its limits are what? Are minus xm and plus xm. So إذا بنلاحظ so رح تروح من minus xm and plus xm. These are the boundaries of x in terms of x. Now, if I want to represent, for example, the potential elastic energy, so I know that for x equals to 0, I have PEE is equals to 0. This means at origin, x is equal to 0, so PE equal to 0. But for x equal plus xm, I will have PE elastic maximum. It's half kxm squared, which is maximum. And at the maximum elongation, I have the speed is equals to 0, which means ke equals to 0. So this means that the potential elastic energy at the maximum elongation is equals to the mechanical energy. So here we go. For x equal to plus xm, I have the potential elastic energy is equals to the mechanical energy. Same thing for the maximum compression. So if I put, for example, here minus xm and square, I'll get the same answer. So also for x equal minus xm, I have PEE maximum. This means this curve here represents the potential elastic energy. And why it's a curve? Since if I notice here, P, it's half kx squared, so in the form of y equal as x squared, which means it's a parabola. Now, let's see half mv squared. Let's see now the kinetic energy. So at t equals to 0, when I have for at t equals to 0, if PEE is equals to 0, this means the kinetic energy is equals to the mechanical energy. So it's maximum. So at t, for x equals to 0, I have a maximum speed. This means a maximum kinetic energy. While for x equals to plus xm, so this is for x equals to 0. For x equal plus xm or x equal minus xm, at the maximum elongation or compression, we know that the speed is equal to 0, which means that the kinetic energy is equal to 0. This means for x equal minus xm, kinetic energy 0, and here also kinetic energy 0. So here we said that this is the potential elastic energy. This means this curve represents the curve of the kinetic energy. So why it's also a parabola? Since if I want to write it, I will say that Ke equal to ME, mechanical energy, minus PE, elastic. And the mechanical energy here, it's a constant. So I can name it, it's any constant, minus, and this is half kx squared, which means this is also a parabola, but we have minus here. So this is why its shape is like this. Now, let's represent the energy, but now in terms of the time. So in order to represent energy in terms of time, this is here the energy, and this is the time. Now I will start with PE elastic. So it's equal to half kx squared, but I want it in terms of time, knowing that x equal xm sine omega 0 t plus 5. So I just substitute, then half k xm squared sine square omega 0 t plus 5. If I notice here, PEE will be a sinusoidal equation, and it's a sinusoidal function, but it's square. This means it's only up from the axis. يعني ما في أرسمها like this. I can't trace it like this. I must trace it above the axis since I have a positive, we have a square here. Now, let's do the kinetic energy. So it's equal half mv square. كمان if I have x, so لطلع v, I say v equal x prime. This means it's half m. If I do the derivative, I'll get xm, and I have this square, omega 0, and the square, and cosine square omega 0 t plus phi. Also, if I notice, it's a sinusoidal equation. So let's see the mechanical energy. Will the mechanical energy be a sinusoidal equation or it's constant? And knowing that there is no friction. So ME equal PEE plus KE, which is equal here, half KXM square, and I have the sine square omega 0 t plus phi, and the plus half M XM square omega 0 square and plus phi. Now here I must notice that I have omega 0 square. So if we remember, omega 0 square is equal to k over m. So if I put k over m and m will be simplified, I will still have half kxm square and half kxm square, so I can take it as common factor. And I will still have inside sine square omega 0 t plus phi plus cosine square omega 0 t plus phi. And this is all equals to 1. So I get half k xm square. These are constant, which means that mechanical energy does not depend on time, it's constant. And this is what we should have since there's no friction. We already said it's an undamped oscillation. So if I want to trace, this will be the constant, the mechanical energy here, ME. Now, which one represent the kinetic energy and which one represent the potential elastic energy? Here, in order to know which one, we'll go to the initial condition. So it's according to the exercise. If they said that at t equals to 0, if at t equals to 0, the spring was elongated, this means x equal to xm. This means that at t equals to 0, I have PEE maximum. So I will look here at the figure. At t equals to 0, أي واحدة منهم maximum هي هيدا بالorange. So this means this one will represent the potential elastic energy. Now, the other one then will be the kinetic energy. So always in order to know which one represents the potential elastic and which one the kinetic, I must look at the initial condition. Now here we have a remark. What is the remark here? The remark is that the period, since it's a sinusoidal wave, then we have a period. But what is the period of the energy? So if I notice, the period of the energy is equals to half the proper period. This means I will have that the period of the energy is equals to T0 over 2. Why is this? Since let's see here on the figure, at t equals to 0, if I notice here at t equals to 0, the potential energy elastic was maximum. Okay, so حتى يبقى عندي one period for the energy لازم ترجع للفاليو اللي هي PE maximum. So when رح ترجع تصير maximum؟ رح ترجع تصير maximum here. Since here I will say PEE equal half K minus XM square يعني XM square. So رجعت لإمتى؟ This means the period of the energy صارت هيدي كلها. Here the time elapsed here is the period of the energy. But we already know that the proper period of the oscillation is a back and forth. So لازم تعمل back and forth لأقدر أحكي عن proper period. إذا بقارنهم ببعض, we will notice that the period of the energy is half the period of the oscillation, means half the proper period. So this is here a remark.